Hello, my pre-calculus friends. This is Pre-Calculus section 12.3, day 2 notes. Today is kind of a red letter day in Precalc because today you are going to learn what the definition of a derivative is. So before we can think about what the definition of a derivative is, we want to go back. And I apologize, I know you don't really have any space to write this in your note packet, so maybe use the margin for where you use your questions, okay? Or where you write your questions to write this down, because I do want you to have the following information. So we're going to go back to the definition that we were working with, the previous day, yesterday, for our slope of a tangent line, which our definition of a tangent line was that our slope is equal to the limit as x approaches a of f of x minus f of a over x minus a. Okay, so we're going to begin with that. That m is equal to the limit as x approaches a of f of x minus f of a over x minus a, okay? So we're just going to do a simple substitution. We are going to say, if we let h represent x minus a, okay? And then if we solved for x would be equal to h plus a, right? Just by adding a to both sides, okay? And then our equation becomes the limit as h approaches 0 of f of a plus h, or h plus a, however you want to say it, minus f of a all over h, okay? And this equation that we just wrote is given a special name in mathematics, and it's called a derivative, or this limit, I should say, is called a derivative. Okay, so now let's go ahead and fill in that box now that we have this information. So the derivative of a function f of x at a number a is written as f prime of a, and it has the following meaning. F prime of a is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. And this, of course, is provided that the limit exists. So let's use this new definition that we just learned for finding a derivative to calculate the derivative of the function f of x equals 5x squared plus 3x minus 1 at the number 3. Okay, so our job here is to find f prime of 3. So that 3 value, basically you could say, is our a value. Okay, so a is 3. All right, so let's just begin with our definition. We know that this is going to be equal to the limit as h approaches 0 of f of 3 plus h, or h plus 3, minus f of 3 all divided by h. Okay, well, f of 3 plus h means that we are supposed to plug 3 plus h into our equation right here for x and right there for x, right, where I put those green x's. So we're going to be substituting in the 3 plus h in both of those locations. And then f of 3 means that we're going to be plugging 3 into both of those locations. So this is about to get messy, okay? Just bear with me because it's going to get messy, and then all of a sudden it's going to get beautifully neat at the end. Just wait and see. All right, so the next step is going to be the limit as h approaches 0 of. Now I'm going to plug 3 plus h in for x in the function. So it's going to be 5 times 3 plus h quantity squared plus 3 times 3 plus h minus 1. That's f of 3 plus h. Minus, and I'm going to use a bracket because we have to minus all of f of 3. So 5 times 3 squared plus 3 times 3 minus 1. And that's all over h. And now obviously we have some math to do here. We've got some foiling to do and some distributive property to do, and then we're going to have like terms to combine. So we're just going to take this one step at a time. So in my next step, I'm going to do the foiling of the 3 plus h quantity squared, and I'm going to do the distributive property, and then in my brackets, I'm going to simplify that f of 3. So this is going to be the limit as h approaches 0 of 5 times 3 plus h quantity squared is 3 plus h times 3 plus h. So when you FOIL that out, you get h squared plus 6h plus 9. Then I've got plus 3 times 3 plus h. So that's going to be 9 plus 3h minus 1 minus, and then inside my brackets, 3 squared is 9, and then 9 times 5 is 45 plus 9 minus 1. And that's all over h. Okay, in the next step, I'm going to distribute the 5 and distribute the negative through the bracket. So I'm going to have the limit as h approaches 0 of 5h squared plus 30h plus 45 plus 9 plus 3h minus 1. And then 45 plus 9 would be 54, minus 1 would be 53. So minus 53, right? Because this whole thing right here is 53, if I combine that together. And this is all over h. Okay, now hopefully you've noticed that there are going to be some nice things that are going to start to simplify here when I combine like terms. So in my next step here, I'm just going to combine my like terms. So I'm going to have the limit as h approaches 0 of 5h squared. I've got a 30h and a 3h, so that's going to be 33h. And then I've got a 45 plus 9, which is 54, but then minus 1 is 53, and then minus 53, that's just gone. We don't have a constant term. And this is all over h. Okay, well now the next step here, I'm going to be able to factor an h out of my numerator. So when I do that and I factor the h out of my numerator, I get the limit as h approaches 0 of h times 5h plus 33 divided by h. And then of course the last step would be, before I do direct substitution, I want to cancel out that h term that gives me 0 in the denominator. So now when I substitute in h and I actually evaluate the limit, 5 times 0 is 0. 0 plus 33 is 33. So f prime of 3 is equal to 33. That one was a long one. All right, next example. When we talk about the slope of a tangent line, you can use either of the methods that we know to find the value of the slope. So you can use the definition of a tangent line, which is what we were working with yesterday, the limit as x approaches a of f of x minus f of a over x minus a. Or you can use the definition that we learned today, which is the definition of a derivative. M is also equal to the limit as h approaches 0 of f of a plus h minus f of a over h. So it kind of depends on what information you're given. So for the next example, I'm going to do it both ways so that you can kind of compare and contrast and you can see how they are similar and how they are different. All right, so our example here is we want to find the slope of the tangent line to the curve y equals x plus x squared at the point 1, 2. So it's important to note that our a value here is 1. Okay, in that ordered pair, a is 1. So first I'm going to use the definition of a tangent line. So I'm finding the slope, which is going to be equal to the limit as x approaches a of f of x minus f of a over x minus a. So for this particular problem, that's going to be the limit as x approaches 1, because my a value is 1, of f of x. Well, f of x is my function, so that's going to be x plus x squared minus f of a. Well, f of a, I know, is 2. That's given to me in my ordered pair. So minus 2 over x minus a. So x minus 1. Well, now hopefully you recognize that the numerator there is a trinomial that can be written in descending order and then factored and simplified. So I've got the limit as x approaches 1 of x squared plus x minus 2 over x minus 1, which I'm going to do another step right here, is the limit as x approaches 1 of, that numerator can be factored. Two numbers that multiply to make -2 and add to make +1 are going to be +2, -1. So x plus 2 times x minus 1 over that denominator of x minus 1. So now as you can see, my x minus 1s are going to cross out. So I end up with the limit as x approaches 1 of x plus 2, which when I plug in 1 for x, I get 3. Okay? So there we go. Now we're going to look at the same example, but this time we're going to look at it using the definition of a derivative. And I will admit before we even begin that this way is definitely going to seem more complicated. Okay, so we're going to begin with the fact that our definition here is m equals the limit as h approaches 0 of f of a plus h minus f of a all over h. Okay, so for my particular problem, okay, I know now that my function that I'm working with here, I'm going to write it up here, is y equals x plus x squared, right? So this is going to be the limit as h approaches 0. So f of a plus h is going to be a plus h plus a plus h squared, that's f of a plus f of h, minus, and f of a, we know from our ordered pair that f of a was 2, right? And actually, we should probably, I'm going to backtrack for a second here. F of a would actually be minus a plus a squared, right? When we're plugging in a. Okay. And that's over, all over h. Okay. So now we're going to have to do some math, and I'm going to use a little bit of my blank space over here to simplify. Okay. So right here, I'm just going to do a little cleanup. A plus h quantity squared plus a plus h minus a squared. When I distribute that negative, a plus h quantity squared is going to be a squared plus 2ah plus a squared h squared plus h minus a squared. And then I'm going to go ahead here and I am going to combine like terms. and I'm going to end up with